Okay, let me go ahead and talk about this one. So we've got 3 sine pi x minus 1 plus 3. Now, I'm going to talk about the vertical first of all. What's going on here with the vertical? Normally, the sine graph will oscillate about the horizontal axis, the y equals 0. Let me go ahead and draw the sine graph, just the basic shape. Looks something like that. Okay, and normally this is the line y equals 0. This is the x-axis, but this graph has been shifted up 3 units. So that line of oscillation is y equals 3. So that's this. This is what the graph oscillates about. So when you're wanting to do a quick sketch of this, okay, I've got this rectangle that's going to contain one period of this graph. This 3 goes right here. Now, the amplitude is here, 3. So what I'm going to do is I'm going to shift up. I'm going to add 3 to this 3. Not shift up, but add 3 to it, and I get 6. That's how I get the maximum of the graph, because I take the line of oscillation, add an amplitude to it, and I get the maximum here. So that's 6. Now to get the low point down here, I take an amplitude away from the line of oscillation, so it's 3. So this graph oscillates between 0, well, I say 3 times 0, it's 3 minus 3, I'm sorry, 3 minus 3 equals 0. Sorry about that. So there's 0 right there. So the line goes, it goes from 0 all the way up to 6. Okay? There we go. 3 minus 3 equals 0. Now, okay, so we're finished with that. So we know what the graph is doing vertically. Then we come back and we say, okay, what's going on horizontally? Well, we've got a couple of things affecting the horizontal. We've got pi right here, and we've got the 1 here. Now this 1 shifts the graph over 1 unit to the right. So it's a horizontal shift to the right. This pi changes the period. It changes the interval that it takes for the graph to make one complete cycle. So here's the deal. The period, so let's think about what the period is. The period is normally 2 pi for just a sine graph. But we've got this thing here that's going to change the rate at which the graph cycles through a period. So what I need to do to get the period of this graph is divide by pi. We get 2. Okay? So the period is 2. Now, here's what happens. Normally this graph of sine, a period of the graph would start at 0, and it would end at 2 pi. Well, our graph, remember, we've got to do the transformation. How are these points transformed? In other words, where does this graph, where would a period of this graph start? Well, one of the periods would start at this transformed 0. We would say 0 divided by b, which is pi, and add c. So it starts at 1. Okay? So this graph cycles through forever. So we're just looking at one of the starting points of a period. The one we're looking at here, 1. So there's infinitely many ways we could do this, but we're just wanting to get an idea about where one period of this graph would start. So we start here at 1, and then for this one, for 2 pi, we're going to divide by pi and add 1. Divide by b and add c. So here's what we've got. We've got 3. So this graph ends over here at 3. Okay, so that's what we're looking for in this graph. Okay, so let's take a look at this. We want to get a quick sketch of this 4 cosine 2 pi x minus 4 minus 2. Now, first thing I want to do, I draw a little rectangle here because I want to represent just a typical period of the graph. So remember cosine, let me see if I can get a good sketch. Okay, something like that. Not too bad. So this is a typical cosine. Now normally the cosine graph, if we're just looking at a period of cosine, we could think of it as starting at 0 and ending at 2 pi. So the period is 2 pi. And normally the cosine graph oscillates about the x-axis, which would be 0 here, and it goes up 1 and it goes down 1. So the amplitude is 1. But this one here is different. It has been shifted down 2 units. So this line of oscillation is no longer 0, it's -2. Okay, so -2 goes right here. So this graph has been dropped down 2 units. Now, in addition, we have the amplitude. So from this line of oscillation, we go up 4. Okay. See? The amplitude. And as far as the low point, we take the -2 and we subtract 4. And we get -6. So this thing oscillates between -6 and 2. So we have a low point and a high point. Okay? So what we have here is the vertical. What's going on with the vertical? Now normally, as far as the period goes, the period for cosine is normally 2 pi, but not for this one, because this one has a b value here. So we divide by 2 pi, and we get the period, the period is 1. So this graph has a period of 1. So from start to finish, it takes, a length of 1 to go from beginning to end. So let's see what the beginning value is. Normally, it starts at 0, but this one, we're going to divide by 2 pi and add c. Well, c in this case is -4. See? It's the opposite of what's in there. Okay? So this graph starts at -4. Okay? Just a typical period. Now this graph, it cycles on and on forever. We're just looking at one particular period. It starts at -4. Now, where does it end? Well, we could divide by 2 pi and add a period to it. Add a -4. Okay. And that's going to be 1 minus 4 equals -3. So it ends over here at -3. See? So this particular graph, you could think of, if you wanted to represent just an arbitrary period of this graph, you could start at -4 and end at -3. And you notice, if I take -3 minus a -4, I would get -3 plus 4, which is 1. And sure enough, we said the period was 1. And we would expect the distance from -4 to -3 to be 1. It better be, because if it's not, we did something wrong. So there's a representation of one period of the graph. Okay, so here we go. We notice that we've got a negative sign here. That's the basic graph. So we just draw a typical graph of negative sign. Okay, looks like that, something like that. And we take into consideration that this graph has been shifted down 2 units. So instead of oscillating about 0, it oscillates about -2. Now we need to get a low point and a high point. So I'm going to take this line of oscillation and I'm going to add the amplitude and I'm going to subtract the amplitude. So this graph oscillates between -4 and 0. See? So if you take -2 and I go up 2, I get 0. If I go down 2, I get -4. So this is what the graph oscillates about. So that takes care of the vertical. So you add and you subtract an amplitude. Now, as far as the horizontal, so let's think about the period in this graph. So the period is going to be 2 pi divided by 2. See? 2 pi divided by b. This b right here. So that's pi. So from start to finish, that length right there is pi. Normally the graph starts at 0, so let's take 0 divided by 2, and we will add pi over 3. So this is pi over 3. So that's where the graph starts, at pi over 3. Okay? That's where this particular period that we're looking at starts. Now what about where it ends? Well, 2 pi normally, but we're going to divide by 2 and add pi over 3. Well, then that is going to give us pi plus pi over 3. And I guess that's going to give us 4 pi over 3. That's where the graph ends. 4 pi over 3. Now remember, the period is pi, so we can check ourselves. If this graph starts at pi over 3 and ends at 4 pi over 3, we can see what the length is. 4 pi over 3 minus pi over 3. Okay? So that's 3 pi over 3, which is pi. Ah, good job. See, it needed to be pi because we knew that was the period. So there we have it. That's kind of a rough sketch of that function there that we're looking at.